we're going to be taking a look at recursion. So recursion is when we write a formula for a sequence of numbers that is based upon the previous terms that we have. So I've written out this example right here. So we have a 1, a 2, 3, 5, 8, 13, so on. So the idea here is that for arithmetic and geometric sequences, we already got like formulas for those that are explicit, like we don't need to know all the other terms, so that's called an explicit formula. But here what we're looking at is when that is not going to be as easy to do. So recursion is when we really need to start with looking at the previous terms first. So this sequence right here doesn't fit into either category of arithmetic or geometric, but hopefully you see a pattern. And that pattern being, if I look at 1 and 1, and 1 plus 1 is 2. And then if I take a look at 3, well, 3 could come from 1 plus 2 is 3, and 5, 2 plus 3 is 5, and then so on and so forth. So what we want is a formula for this. So the first thing we're going to want to do is understand that A1 represents the first term. So I know I had the first term, and I just identified my pattern. Well, A2, the second term, I don't really have a way to get that exactly based upon this. So I'm just going to say A2 is 1. But now what I want to do is use these two to write my formula. So my formula will be in the form A subscript n equals, well, now let's think. How do I get this term? Well, by adding the previous two. So I might say, well, that equals A2 plus A1, but I want any term number. So that would give me term 3. So if I take a look at the next term, term 4, well, how do I get that? That's going to be A3 plus A2, and hopefully you're seeing a pattern with all these subscripts right here. So if I wanted to do n, well, it's the previous two terms. So from 2, if this is an, then this is a sub n minus 1, and this is a sub n minus 2. So I could write this formula as a sub n minus 1 plus a sub n minus 2. So what does this mean? This represents the term I'm on, and this would mean the previous term, whatever that happens to be, and that would represent 2 terms ago, 2 terms back. Now, you could write your recursive formula a different way. You could say a sub n plus 1, meaning the next term, and then a sub n, the term I'm on, plus a sub n minus 1. These two are essentially saying the same thing, but in a slightly different way. Okay, so let's take a look at actually using a recursive formula. So I've written 4 recursive formulas right here. So I have my first terms 3. Now let's say that for each of these I want to find the first 3 or 4 terms, or the next several terms. So if I wanted to know A2, well, that's going to be 2 times, well, what's the previous term? Here, n would be 2, meaning the second term, which means this, n minus 1, that would be the first term, so times the first term, which is going to equal 2 times 3, which is 6. Now, if I wanted my third term, that's going to be 2 times, so this is the third term. This would be n. N is 3, which means the previous term would be the second term. So that's going to be 3 times, well, my previous term was 6, because a sub 2. So I get 18 right there. And if I wanted the fourth term, that's going to be 3 times, so n is 4. So the previous term was the third term, so that's 3 times 18. So if I want to do 3 times 18 real quick, I get 54, so 54, and this would just pattern would go on. So the next few terms would be 6, 18, and 54. Now, Of course, writing a recursive formula for this one actually doesn't really make sense because I have always times the 3 right here, right? I'm always multiplying by 3, which tells me that this is geometric, and we actually have a better way to write a geometric formula with an explicit formula that we've already gone over. Let's take a look at this next one. So we start on -5, and we have our recursive formula. So A2 is going to be A1. Oh, well, that's not the order I wrote it in, plus 4. So that's going to be -5 plus 4, which is -1. The third term is going to be, I'll write it in the right order, 4 plus the previous term. The previous term is A2, which is 4 plus -1, which is 3. And A4 would be 4 plus A3, the previous term, which is 4 plus 3, which is 7. So there we have our answer right there. But for this one, again, we're adding 4 each time, right? We're adding 4. So this one was arithmetic. So again, we do have a better formula for an arithmetic than this one, an explicit formula that we've already gone over. So recursion, really we want to use recursion when we don't have that explicit formula. So here's a good example of a time where it's not arithmetic. This is, we see we're multiplying by 2 and we're adding by 7. So now this could be, we'll see if we could write it as an arithmetic formula, but let's find out. All right, so we have A sub 2, and that's going to be 2 times the previous term. That's what this means. So if I want 2, then the previous term is 1. So that's going to be 2 times 5 plus 7, which is 17. So I'll just list these right here, see if it is arithmetic. So 3. The third term is going to be the previous term plus 7. So 2 times the previous term, 17, plus 7. So 2 times 17 plus 7. And get 41. And now my fourth term would be the third term times 2 plus 7. So 2 times the fourth term, that's 41, plus 7. So 2 times the fourth term, plus 7, get 89. So I have 41, 89, and is this arithmetic? Is it adding the same thing multiple times? So if we have plus 12, and then this is obviously not plus 12, so obviously not arithmetic. All right, next one, 32, and we're going to have it and then add 2. So let's go ahead and do the second term. So a half. Now notice this is n plus 1. So this is meaning the next term, and this means the term I'm on. And the term I'm on is term 1, and the next term would be term 2, but essentially it's doing the same thing as the others. It's just a different way to say it. So 32 plus 2. So that's going to be 16 plus 2, which is 18. So that would be the next term, 18. A3, a half, the previous term, 18 plus 2. Okay, so that's 9 plus 2, which is 11. So the next term's 11. The fourth term would be a half of the previous term, 11 plus 2. So a half of 11 plus 2, was it? 7.5. So that's the next term. Okay, so where we really want to go, using them, that's a good skill, but where we really want to go is actually writing them. So let's see if we can write a few of them. So write a recursive formula. So we're going to want to struggle through this, see if we can find a pattern. So looks like I'm easing you into it. I see a pattern. So I like to do this, like write a pattern up here, see if I can identify what's going on. I am adding 7 each time. So I could write, and let's go ahead and write it just for practice. I could write the arithmetic formula for this because it is arithmetic. And we are adding 7 each time. So in that case, it'd be a sub n equals, so our first term, which was 3, plus our common difference is 7 and n minus 1. So we don't want to forget that form for an arithmetic common difference n minus 1. But what we're asked to do is write a recursive formula. So a recursive formula is going to be based on the previous terms. So my first term, we'll start there, is 3. And I see that I add 7 to the previous term each time. So a sub n is going to equal a sub n minus 1, the previous term, plus 7, because I add 7 to the term before it each time. So there's our answer. Of course, these can get a little bit tricky. So let's see here, times 4, times 4, times 4. So this one is geometric, and just for the practice, let's see, can we write the geometric formula for this one, just as a little review. So that has the form a sub n equals a sub 1 times our ratio to the n minus 1. So this one would be, our common ratio is 4. So it's going to be 5 times our common ratio 4 to the n minus 1. So this is our geometric formula for it. But again, we aren't asked for that. We are asked for the recursive formula. So this is all based on the previous term. So the previous term is 5. So a sub n is going to be the previous term times 5. So 5 times the previous term, and that's how I'm going to write my previous term. Now, it's just to note, you could get different answers for this, and those different answers be correct. So it would be correct to also write it like this. So this means the next term equals 5 times the current term. No little mark there. Those are also the same thing. Okay, so this one. Let's see what's going on this example. So these two were arithmetic and geometric. This one is neither of those two things. So let's see here. Plus 1, plus 0, plus 2, plus 4. Okay, so I do notice a pattern here. Plus a lot more. So, but it's not a plus, is it? It's, well, what is it? Here it's times 2, times 2, times 4. I actually think that's a mistake. I think it's supposed to be a 16 right here. So I'm going to change it. That should be a 16 times 2. Oh, no. That shouldn't be a 16. What am I talking about? Derp to derp. Because it's not geometric, right? That's what I said. So it's neither of those, but if I take a look, 2 times 4 is 8. 4 times 8 is 32. So how do I get these first two? How do I get these two terms? Well, I just start with those two terms. So a sub 1 is going to be 1. A sub 2 is going to be 2. And then I see, well, how do I get this 2? Well, it's by multiplying those two. And how do I get this 4? Well, by multiplying these two. So it's the previous thing. So how do I get the 32? Well, 4 times 8. So a sub n equals the previous term times the term before that one. 2 terms back. And another way to write that would be a sub n plus 1 equals the current term times the term before it. So both of these answers would be correct. Okay, so let's continue on. That's the trick, is writing these formulas, and it can be a struggle sometimes. So write a recursive formula here. So I'm going to try to find a pattern up here, see if I can see what's going on. If I add these two, I don't get 9. If I multiply them, I don't get 9. But if I add 2, so 5 plus 2 is 7, 7 plus 2 is 9, 9 plus 2 is 11, 13, or 11 plus 2 is 13. So it's almost arithmetic, but notice I have a negative going on here. So something that we want to do is we want to try a formula, test it to see if it works, and then make any changes that we might need. So what I'm going to write in blue right here is my guess. So I'm going to guess that I start at 5. That's a pretty good guess. I definitely start at 5. And I'm going to guess a sub n equals the previous term plus 2. Okay, so if we test that, we would get 5, and then 5 plus 2 is 7, not negative 7. And if I did 9, okay, if I wanted to get 9, well, that would be 7 plus 2, but that's a negative 7. So how am I going to get the negative? So I know it's going to be this. This checks out except for the negatives. So how could I get this term? So if I wanted to get this 7 from this formula to be negative, I would multiply it by negative 1, right? So my next guess, I'm going to put in this ugly yellow right here. Hopefully it shows up. My next guess is that I need to multiply by negative 1. So I'm going to do negative 1 times a sub n minus 1 plus 2. So let's see if we get that. So if I do the previous term, so if I wanted a2, that would be negative 1 times a1 plus 2. So that would give me 7 times negative 1, which is negative 7. So that worked. So we check out for that term. So a3 would be negative 1 times the previous term, a2. Well, a2 is negative 7, so we are going to run into a problem here. And that would be negative 5 plus, yeah, that would be not what we want, because this would be negative 5, and then I get a plus 5 right there. So that does not check out. So it appears I'm going to have to do something a little bit more complicated. And this is one way that you could actually do this question, one answer. I'm going to say I'm adding 2 to the absolute value of the previous term. All right, so that gets me there. But, so I ran out of space there. Every other time I need to multiply by negative 1. So how am I going to show that? Well, I'm going to do negative 1 to the n minus 1 times the absolute value of n minus 1, I want all of this in parentheses, plus 2. So this is a solution to that. It isn't necessarily. Let's check it. So I'm going to check it with, say, if I want the fifth term. So I know that the fifth term should be 13. So that's going to be negative 1. Now this means, now if n is 5, so n is 5, that means n is 4, or this number's of 4 right here. So 4. The absolute value of the previous term, so the absolute value of negative 11 is 11, plus 2 is 13. Now what's negative 1 to the 4th? Well, that's 1. So I get 13. So that checks out. So an answer for this is not any of this stuff. A possible answer is to say negative 1 to the n minus 1 times the absolute value of a sub n minus 1 plus 2. Or written another way, a sub n plus 1, our next term, equals negative 1 to the n, meaning our current term. So notice if I shift this up 1, then I shift all of these up 1. Absolute value of a sub n plus 2. Sorry, that kind of was messy. All right, let's take a look at this one. So let's see if we can find a pattern. It looks like, let's see, since I made these all up, who knows? So times 2 times 2 times 2, it looks like times 2. So it does look geometric. So if we were to write a geometric on this one, it would be times negative 2, right? So I could write a geometric formula for this one, but I want a recursive formula. So a sub n, or the a sub 1 is negative 2. And then using a recursive formula, I do the previous term. So that means the previous term, but times negative 2. So that one was pretty easy. Sometimes they hard, sometimes they easy. All right, this one. Let's see here. So I like writing on top of it, just little pluses and minuses to see what I get going on here. It looks like this one plus 8. And if I were to do 27 minus 11, okay, looks like plus 16. And if I were to do 59 minus 27, I get plus 32. And I see that each time I'm multiplying these that I'm adding by 2. Right? So that tells me I'm doing something weird with my terms. So I do start at term 1 being 3. Now let's think, how can we get to 11 from here? Well, I'm going to take a guess. I'm going to guess, because there's a times 2 on each of these, I'm going to guess it's the previous term times 2. All right, so if I did 3 times 2, I get 6, right? That's not 11. And if I do 11 times 2, that's 22. So if I start writing these out, I get, with my formula so far, I have 6, and I would have 22. And then if I did 27 times 2 for my previous term, so 27 times 2, I get 54. And I see for every single one of these, it should be 11, it should be 27, it should be 59. I am 5 off. All right, add 5. So let's test it. Let's test my formula. So if I did a sub, let's say I wanted a sub, well, the biggest one I have there is 59, but let's try the 27. So that's the third term. So the third term would be 2 times the previous term. So that would be a 2, and then plus 5. So equals 2 times the previous term is 11, plus 5, so that's 22 plus 5, 27. So when you get your formula, you do want to check it. I checked it only one time, and it's possible that your formula works for like the first few, but not the last few. So you actually want to do more of a check and make sure it actually fits all the numbers that you have. Oh gosh, holy, that's a huge number. Hopefully I don't need to use it. So I'm going to start this with looking at my pattern. So I do have a plus 7. Oh boy. So pluses are not going to help me. So if I did 730, subtract that 9. Okay, so 721. So plus 721. Yeah, and then plus something huge. Pluses not going to get me there. So what about times? What do I have to multiply 2 by to get to 9? Well, not a nice number, but almost times 4. And what do I have to multiply 9 by to get close to this 730? Let's see. So 730, let's go ahead and divide that by 9. See what we get. 81. So if I did 9 times 81, what do I get? 729. Oh, almost. So if I did times, what was it, times 81? Okay, the next one. Now, I don't want to try to play with this one if I don't have to. So let's see if we can figure it out with just these. So the pluses, not helping me out. Now the timeses, I do see a relationship between 2 and 4, and I do see a relationship between 9 and 81. So if I did 2 times 2, I get 4, and that's what I multiply by. And if I did 9 times 3, I get 81, and that's what I multiply by. Now, I didn't get it exactly, but we can fix that like we did up here. Maybe something else is going on. So, let's see. This 4 could be 2 times 2, and then that's 2 cubed. And if they did this 9, well, that 9 is 3 times 3, and times 81 times 3 times 3 times 3. So to the 5th? Okay. It does look like I'm making progress here. I know it doesn't look like it. 3 to the 5th. So we got to remember everything's based on the previous term. So let's try to get this second term based on this 2 one. So here's what I'm thinking. I do think I'm cubing stuff. So I'm going to take a guess, and that's important to do. Just take a guess. And I'm going to guess. So this is my guess. I'm going to do the previous term cubed. All right? So if I do the previous term cubed, well, what's 9 cubed? 9 cubed, 729. And what's 2 cubed? 8. Okay, so I'm off by how much? I'm off by 1, right? So if I take a look at, well, what's 730 cubed? A really big number, a 0 at the end, a 1 at the end. So I'm off by 1 each time, so add 1. Boom, got it. So this gibberish down here, you might be wondering, how did he even come up with that? Again, I'm guessing something. So I'm trying to find something that might stick, and I saw that 2 cubed gets me close to 9. I saw that 3, however many times I have here, I think I might actually be missing a 3. Let me see. I think I'm missing a 3, but let me make sure. Yeah, I am missing a 3. So this should have been to the 6th. But my point being is that once I know that for a recursive formula, I have to use the previous terms. And I just started with plussing. I didn't see anything that was going to take me anywhere. Then I switched to multiplication. I'm seeing, okay, can I multiply and get close? And I could. I was getting close, but it wasn't consistent enough. So then I switched to exponents. So you just try some things and you basically guess and test is what I'm saying there. All right, so many recursive formulas come down to multiply something and add or subtract, or divide right here, something. So a combination of those two things. Now that's not always the case, as we saw in one of the previous examples with the absolute value. So let's take a look at this one. This one's going to be actually pretty tricky. So as I look at this, I can tell right away that repeatedly adding something is not going to work out. I'm not necessarily going to see a pattern. So like here, I see +8. Right here, I see +12. And right here, let's go ahead and figure that out. 40 minus 22, I see 18, so plus 18, although each of these do go up by 6 each time. So do you see that? Let's see if that pattern continues. So the next one, 67, let's see what we added right there, 27. Okay, so, and then if I see a pattern to the patterns, maybe there's one, plus 4, plus 6, plus 9 more. So I do see a pattern emerging right there, but how do I write it with some math? All right, so I want to get close, and sometimes we're not always multiplying by a whole number. Sometimes we're multiplying by a fraction. So if I did like 2 times 5, I get 10, but if I do 10 times 5, I get 50, and I'm way off. And if I do 22 times 5, well, then I'm even further off. Let's see, 22 times 5. Yeah, 110. Yeah, so that's no good. So I might think, well, something smaller. So if I do times 4, I get 8, and I'm only off by 2, so that's not too bad. And if I do 2 times 4, I'm 40, and then we see that now why am I doing, remember, recursion is based on the previous term. And if I see, well, 2 times 10 is 20, and then 10 times 22 is 220, so it's not based on the previous 2 terms. So I'm going to go back to this times thing right here. Times 3 gives me 6. If I do 10 times 3, I get 30. And if I do 22 times 3, I get 66. So that's getting a little bit better. Well, maybe, what if I divided also? What if I divided by 2? Well, this would be 15, and this would be 33, and this would be, so let's do the next one. Let's do one more. So 40 times 3, that gives me 120. If I divide that by 2, I get 60. So do you see what I'm doing here? I got them close with a times 3, and if I divide by 2, so if I divide this one by 2, I would get 15. And now I'm off this one by 7. Plus 7 gives me 22. And if I take this one, 66, and if I divide that by 2, I get 33. And if I add that by 7, I get 40. Now if I divide this 120 by 2, I get 60. And if I add that by 7, I get 67. So it seems like I have a pattern right here. Well, how did I figure that out? Well, again, a lot of them come down to just multiplying and adding something. So I got to remember, I could add or I could multiply by fractions. So here's my guess. So always, don't just give up on them. Take a guess and see if it leads you anywhere. So my first term's 2. So my next term is going to be the previous term times, so what did I do here? I did times 3 and then I divided by 2. Times 3 halves. And then I saw I was off by 7 each time, so plus 7. So I'll just reorganize this. And you want to be way neater than I am in how you write this and make sure it's clear what your subscripts are. So let's test it. So if I wanted the second term, that should be 3 halves times the first term plus 7. So that would be 3 plus 7, which is 10. And that worked out. And I already checked them for the others, so I was just checking the second term to make sure it worked. All right, so this is our formula for that one. So this question is just an extension of that. So I get this alternating negative. So how am I going to get that in there? And for recursive formulas, generally the way to get that is to take what you just figured out. So we just figured out this. Let me write that a little bit differently. And then multiply it by -1, and I'll put it at the end so I have room. Multiply it by -1, but I don't want to multiply by -1 every time. Multiply it by -1 every other time. So this would be an odd term number. So this is an even term number. So no, I could do a -1 right there. So it'll be all the odds will be negative, or all the even terms will be negative. So if I try that, let's try A3. So that'd be 3/2 times the previous term. So this is the third term, so times -10. Oh, absolute value. Need the absolute value in there. That's okay. Let's add that absolute value. So absolute value of that, plus 7, and -1 to the second. All right, so see, yeah, I didn't catch that absolute value right away. So that's going to be 10. That's going to be 5, 15, plus 7, that's 22. And then -1 squared, that's 1, so 22. So that's going to work. So we need an absolute value on there. So the final answer for that last one would be 3/2 times the absolute value of the previous term plus 7, and then -1 squared. All right, so some of these recursive formulas can get really, really tricky. So don't give up. Try something and see what you can come up with. And realize there are multiple ways to get the answer.